Let us begin with Introduction to Trigonometry. Imagine you're in front of a huge building and looking at the topmost of the building. A right-angled triangle can be imagined to be made. Can we find the measure of this building without even manually measuring it? Yes, we can measure the height, width and altitude of the building without even measuring it with the help of trigonometry. So, what exactly is trigonometry? Trigonometry actually means the black part trigono refers to triangle and the red part metry refers to measure. It's just the measure of all the possible things in a triangle. Therefore, trigonometry is a branch of mathematics that studies the relationships between sides, angles and length of the triangle. Now, let's consider a triangle ABC. Now, let us mark side A opposite to the angle A and similarly side B opposite to angle B and side C opposite to angle C. Here, what all measurements can we find from the triangle? The only possible measurements are to find the length of A, B, C and angles A, B and C respectively. These are the only 6 measurements which we deal in trigonometry. Now, let us discuss the ratios of the sides of a right-angled triangle with respect to its acute angles, which is called the trigonometric ratios. Let's consider a right-angled triangle ABC as shown in the figure. Now, from the triangle, we see that the side BC is opposite to angle A. This side faces angle A and is called as the side opposite to angle A in the triangle. AC is the hypotenuse of the triangle as that is the longest side of the right-angled triangle. And the side adjacent to angle A is AB, which can be called as the side adjacent to angle A. Now, let us define the ratio of the sides of a right-angled triangle, which is called the trigonometric ratios. Side opposite to the angle A by hypotenuse is called the sine of the right-angled triangle. Side adjacent to angle A by hypotenuse is called the cosine. Side opposite to angle A by side adjacent to angle A is called the tan. Now, let us reciprocate the ratios of sine, cos and tan. Reciprocal of sine is called cosecant of the right-angled triangle, which is hypotenuse by side opposite to angle A. Similarly, reciprocal of cosine is secant of the right-angled triangle, which is hypotenuse by side adjacent to angle A. And reciprocal of tangent is cotangent of the right-angled triangle, which is side adjacent to angle A divided by side opposite to angle A. Therefore, the trigonometric ratios of an acute angle in a right-angled triangle expresses the relationship between the angle and the length of its sides. Understanding and memorizing the ratios is quite hard. So, let me introduce a small table to make it easier. Here, have 6 columns marked with alphabets O, A, O, H, H and A, where O is the opposite, A is the adjacent and H is the hypotenuse of the right-angled triangle. And mark sine, cos, tan, cosine, sec and cot respectively on each of the boxes in order. Now, have a look at this table in a vertical way from the top. Side opposite to angle by hypotenuse gives you sine, side adjacent to angle by hypotenuse gives you cos, side opposite to angle by side adjacent to angle gives you tan. Similarly, have a look at this table from the bottom. Hypotenuse by side opposite to angle gives you cosec, hypotenuse by side adjacent to angle gives you sec, and side adjacent to angle by opposite gives you cot. So, just studying this table in order reduces confusion of studying trigonometric ratios. Therefore, we write as sine A, which refers sine of angle A, and similarly the others. Note that sine A is not the product of sine and A, but it's the sine of angle A. Similar interpretation follows for other ratios as well. Therefore, the corresponding ratios according to the right angle triangle are sine A is BC by AC, cos A is AB by AC, tan A is BC by AB, cosec A is AC by BC, sec A is AC by AB, and cot A is AB by BC. Now, let us mark a point P on the hypotenuse AC and a point Q on AC extended from the right angle triangle ABC. Thereafter, draw PM perpendicular to AB and QN perpendicular to AB extended. Now have a look at this figure. We have three triangles, namely triangle PAN, triangle CAB, and triangle QAN. Let's look at the triangle PAN and triangle CAB. How are the trigonometric ratios differing in these triangles with respect to angle A? Don't you think the triangles are similar here? Therefore, by the property of similar triangles, that is, the corresponding sides of the triangles are proportional, we have AM by AB is equal to AP by AC, which is equal to MP by BC. Now, let us relate the sides with the trigonometric ratios. That is, from the figure, we find that MP by AP is equal to BC by AC, which is equal to sine A, as that is opposite by hypotenuse. Similarly, AM by AP is equal to AB by AC, which is equal to cos A, and MP by AM is equal to BC by AB, which is equal to tan A. This shows that the trigonometric ratios in triangle PAN does not differ from the triangle CAB. In the same way, we can check triangle QAN also with the other triangle. From our observations, it is clear that the values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle, if the angle remains the same. Sometimes Greek letter theta is used to denote angle instead of A. For example, sine A can also be written as sine theta. Let us now have a look at what is Pythagoras' theorem and how is it related to trigonometric ratios. It is a triangle in which one angle is right angled. Pythagoras' theorem says that hypotenuse has the special relationship with the other two sides of a right-angled triangle. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse side is equal to the sum of squares of the other two sides. This condition is true only in the case of a right-angled triangle. Let us consider a right-angled triangle with lengths A, B, and C. Therefore, A square is equal to the sum of B square and C square. Now, let us incorporate the Pythagoras theorem in the trigonometric ratios. Let us consider a right-angled triangle where sine A is equal to 1 by 3, which means that BC by AC is equal to 1 by 3. Therefore, the lengths of the sides BC and AC of the triangle are in the ratio 1:3. So, if BC is equal to K, then AC will be 3K, where K is any positive number. Now, to find out the other trigonometric ratios for the angle A, we need to find the length of the third side AB. Let us make use of Pythagoras' theorem to determine the length AB. From the Pythagoras theorem, AC square is equal to AB square plus BC square. Since we need AB, we rearrange the equation to AB square, which is equal to AC square minus BC square. That is, by substituting the values of AC and BC, we get 3k to the whole square minus k square, which is equal to 9k square minus k square, which is equal to 8k square. That is 2 root 2k to the whole square. Therefore, we get AB is equal to plus or minus 2 root 2k. So we get AB is equal to 2 root 2k. From the triangle, we know that cos A is AB by AC. That is 2 root 2k divided by 3k. Cancelling out the k's from numerators and denominators, we get 2 root 2 divided by 3. Similarly, you can obtain the other trigonometric ratios of the angle A. Consider an example: tan A is equal to 5 divided by 12. Now, let us try to find the trigonometric ratios of angle A. Since tan A from the table is opposite by adjacent, let's draw a triangle with corresponding values. Here, in the triangle, the opposite is given as 5 units and adjacent as 12 units. From the given data, BC by AB is equal to 5 divided by 12. Now, if BC is 5k, then AB is equal to 12k, where k can be any positive number. Now, let us use Pythagoras theorem to find the hypotenuse, which is the longest side. That is, AC square is equal to the sum of AB square and BC square, which implies that 5k square plus 12k square is equal to 169k square. Thereby, AC square is equal to 169k square. Cancelling out the squares on both the sides, we get AC is equal to 13k. Now, let us find other ratios as we have all the sides of a triangle. That is, sin A is equal to opposite by hypotenuse, which is equal to 5 on 13. Cos A, which is equal to adjacent by hypotenuse, that is 12 on 13. And to find the cosec, sec and cot, let us take the reciprocals of sine, cos and tan. That is, cosec A is equal to 1 by sine A, which is equal to 13 on 5. Sec A is equal to 1 by cos A, which is equal to 13 by 12. And cot A is equal to 1 by tan A, which is equal to 12 by 5. Now, let us consider a problem. If 3 cot A is equal to 4, let us check whether 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A or not. From the given data, we see that cot A is 4 by 3. Let us now draw a triangle. From the table, cot A is equal to side adjacent to angle A divided by side opposite to angle A, which is equal to AB by BC, which is equal to 4 by 3. If AB is 4k, AC is 3k, k can be any positive number. Now, in triangle ABC, let us find the unknown side. That is, AC square is equal to AB square plus BC square. Substituting the values, we get AC square is equal to 4k square plus 3k square. AC square implies that 16k square plus 9k square, which is equal to 25k square. AC is equal to 5k. From the question, we identified that we need the values for sine, cos and tan. Let us find the trigonometric ratios of the same. That is, cos A is equal to side adjacent to angle A divided by hypotenuse is equal to AB by AC, which is equal to 4k by 5k, giving you 4 by 5. Sin A, which is equal to side opposite to angle A divided by hypotenuse, which is equal to BC by AC, that is 3k by 5k, giving you 3 on 5. Now, tan A is equal to side opposite to angle A divided by side adjacent to angle A, that is BC by AB, giving you 3k by 4k, which is equal to 3 on 4. Now, let us consider from the data 1 minus tan square A divided by 1 plus tan square A and substitute the values. That is 1 minus 3 by 4 the whole square divided by 1 plus 3 by 4 the whole square, giving you 1 minus 9 over 16 divided by 1 plus 9 over 16. That is 7 by 16 divide the whole by 25 by 16, which is equal to 7 on 25. Now, let us see if we get the same values for right hand side, that is cos square A minus sin square A. By substituting, we get 4 on 5 the whole square minus 3 on 5 the whole square, which implies 16 by 25 minus 9 by 25, giving you 7 by 25. Therefore, we see that left hand side is equal to the right hand side. Hence, 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A. Let us summarize. Trigonometric ratios are given by sine, cos, tan, cosec, sec and cot respectively. Therefore, sine is given by opposite by hypotenuse, cos is given by adjacent by hypotenuse, tan is given by opposite by adjacent, cosec hypotenuse by opposite, sec hypotenuse by adjacent and cot is given by adjacent by opposite respectively.